Hi there, I thought I would graph or tape a video on graphing radical functions, and this is what we did today in class on 11/2/2015. So what we talked a little bit about today was parent functions, and looking at this information here, the parent function of the function f of x is equal to the square root of x looks like this. And in some classes today, I talked about if I had an x and a y chart, and I know that y is going to equal the square root of x. At 0, when x is 0, y is going to be 0. And when x is 1, y is going to be the square root of 1, which is 1. So I come here, and it's 1, 1. My next one is I go to 4. So I look at 4, and the square root of 4 is going to be 2, and the square root of 9 is going to be 3. So I picked those perfect square numbers to do. Now, looking at this graph also, and this is the graph you can get from graphing on your graphing calculator, but you also can get from graphing it from an XY chart. We talked a little bit today about domain, and the domain of functions is just the functions, all of the x values for the function. And in this case, the x values can be 0, and they can go all the way up to infinity. And the range are my y values, and they can also go from 0 all the way up to infinity. So my domain would include 0 and go all the way up to infinity, and my range would go from 0 all the way up to infinity. Now we had some transformation rules, and this was just for moving this graph over. So we can move it right, we can move it left, we can move it up, and we can move it down, and we can also reflect it. And reflect it means that instead of having the square root of x, I have the opposite of the square root of x. So here, instead of being 1, it's going to be negative 1. And instead of being 2 as my y value, it's going to be negative 2. And instead of being 3 as my y value, it's going to be negative 3. So in that case, this particular function is going to look like, well, we're going to graph that, and then we're going to take that and graph there, and then we're going to take this and graph here. So your function is going to look like this, for f of x is equal to the negative square root of x. So that's what it would look like if I reflected it. Now, if you look over here to the side, it gives you some rules. And this means if I am underneath the radical here, and I am moving it, it's going to have minus some number. And this h value tells me, if it's minus, that I'm going to, I'm going to move it to the right, h number of units. And if it's a positive under the radical, I'm going to move it to the left a certain number of units. And then if it's outside the radical, so I have plus k here, I'm going to go k units up, or I'm going to go k units down. So let's practice some of that. Now, my first function I have is, it's going to be the parent function, so it's this one up here, and it's outside the radical. It's not under the radical, so in this case I look for this situation right here, and it tells me that I'm just going to move my graph up 1, 2, 3, 4, 5 units, and then it's going to be 1, 1, and then I can go 2, 3, 4, and go up 2, and 5, 6, 7, 8, 9, and then up 3. So my graph is going to look something like that. And that's what you would see. Now what I'm looking for your graph is the fact that you have moved up the starting point of 0, 0 up 5. So my starting point is going to be 0, positive 5. And whenever I do my transformation, I'm going to say up 5. Now in class today, we talked about the parent function of the cube root of numbers. And so we went down to the bottom of the page, and we decided that this is what y is equal to the cube root of x, that my function is going to look like this. So this is my parent function. And we changed my even numbers to the cube root instead of doing the square root, so to do something different. And in this case, I have negative 2 under the radical, so I know I'm going to go right 2, And so my parent function is my cube root of x, so it's going to look something like this. And we're going to say right 2. Now, moving on to number 3, we're back to the square root function, parent function. So it looks like I'm going to move it to the left 1, 2, 3, 4. And the reason I move it to the left are my rules up here. I'm moving it to the left 4 units. And so my parent function is going to look something like that, or my new function is going to look something like that, with the starting point at 4, 0. And over here, I'm back to where it's the cube root, and I know I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I just do my parent function again, but it's passing through the point 0, negative 6 this time. Flipping it over, some of these change a little bit. So I forgot to do my transformations here. I'm going to go left 4 is my transformation, and down 6. Now if we flip the page, it becomes a little bit different because we're doing a couple of different transformations here. So I have the parent function of a square, so I'm going to change this to a cube over here. And I'm going to go left 2 and down 4. So I have left 2 and down 1, 2, 3, 4. And so it's just going to look like this. My next, and you can do I'll do domain for this and range for this. So my domain is going to start at negative 2 and go to infinity. And my range is going to start at negative 4. So this is my range. My y value starts at negative 4 and goes to infinity here. So hopefully that helps a little bit. Looking over at this one, it appears that we are going to go right 4 and up 2. And my parent function is the cube root, so I go right 4, 1, 2, 3, 4, and I'm going to go up 2, so this is what it's going to look like, and I'm going to look something like that. And for this situation, it appears that my domain is going to be all real numbers, and then my range is going to also be all real numbers, because eventually it will go to cover all the values of y and x. Looking a little bit at these over on this side, I'm going to just take number 6, for example, and here I have a 3/4 on the outside. So that means I'm going to shrink it by 3/4. I'm going to move to the left 3 and down 5. So I start here and I go to the left 3 and down 5. And every single point is shifted a bit. So it's going to be a little bit skinnier. Okay? And that's what the 3/4 means. If I multiply it by 4, it's going to be a little bit bigger. And so it would go shoom, swoop a little bit more. So hopefully that'll help you do your homework tonight.